Okay, welcome back again to question number 5. A disk C spins at a constant rate of 2 revolutions per second counterclockwise about its geometric center G, which is a fixed point P on the x-axis of an xy coordinate system centered at P point. Okay, good, cool. And the particle axis. Okay, not a problem. So we're drawing a free body diagram here. So we have our body in our y, in our x direction, where we have our G point in the center. This is our P point, and this is our R point. Okay, and over here we're given that the radius of 1 meter, so that means this is going to be 1 m and 1 m. Therefore, 1 m and GP equals 1 m. This denotation here, denotation, means that it's the distance between G and D, G and P, pardon me. So it's this 2 points. Let me just make it more clear. It's this G point and this P point right here. Okay? And then we're ready to go. So when we are finding the angular velocity, we are given that the omega c, one more thing, omega c, okay? Omega c equals to 2 revolutions per second. And 1 full revolution equals to 2 pi. So 2 pi times 2 revolutions per second equals 4 pi radians per second. Okay? This is just an aside, okay? So we can use that for later. B, what is the angular velocity of the disk omega c? Okay, so that's when we gotta use this. Okay? Conventionally, counterclockwise, this direction is always positive. This direction is always positive. This direction for angular velocity is always negative. Okay? This is from your right hand rule. Okay? So when our thumb is pointing upwards, right? Thumb equals to your K, only for this case, okay? When you curl your fingers, right, in your counterclockwise direction, your thumb is pointing upwards. That means that this is positive, okay? And the other way around, negative, okay? You don't really need to write this. This is just an aside, but here we go, okay? How we do that? Omega c. So we don't know if it's positive or negative, but since it says positive, so 4 pi rads per second, that equals to 12.565 rads per second. Okay, we didn't really need to do much. If you want, you can put this over here, but it doesn't really matter, and that would be good. Okay, good. And it needs to be in the positive direction. Okay, positive, highlight, because this says that it was in the counterclockwise direction. Counterclockwise. Okay, if it said it was the clockwise direction, then it would be a negative. Okay, let's go to number C. Okay, it asks us for the acceleration. Okay, and we know that it spins at a constant rate. That means that the acceleration equals to 0. Because if I were to do this, we just take this dot means derivative equals to derivative of vector c and dt equal to 0. Because since the constant is always 0. Okay, this is the proof for this part. Okay. Excuse me. Okay, hopefully you're good at a cross products, because we've got to do some cross products here. The next question, it says, what is the angular acceleration of D, what is the velocity VP? Okay, VP of point P, velocity of VP at point P. That's not too bad because we know how to do everything we need to do. So VP equals omega c cross RC. Okay. as r, okay, since it equals to GP, we can write this as 1I. Omega c is in the 4 pi radians per second k hat. Okay? And we know our I, J, K goes this way, right? Since I am going omega c, which is a k cross I following it, so it's going to be a positive j 4 pi. Okay? So that means that VP equals 12.566 meters per second J hat. Okay? Once again, because this needs to be in order when we multiply. Okay? We cannot do R times omega c, which is that when we're doing vector. Okay, we must follow this convention, which is VP equals omega r. Okay, omega r. Because if we do not follow this convention, then we will get this as a negative. Okay, negative VP equals to, VP equals to negative 12.566. So we must keep this in this direction here. Okay, there's no other way. Good. And now we're doing E, okay? E is very simple as well. Okay. Angular acceleration. Okay, of P. That equals to the angular acceleration of the disk. Since it's constant, therefore A equals 0 as well, radians per second. Hope this helps. This finished my question on physics question number 5. So a couple key things. Remember, free body diagram, we of course need to know how to do it. This is your right hand rule, okay, your positive negatives based on your right hand rule. And thumb is your K in this portion only, okay? It might not be true in some other cases. So yeah, hope this helps and have fun.